In Chapter 5, we'll be working with quadratic functions. So today, we're going to be introduced to quadratic functions. Woo! It's going to be exciting. In this set of videos, you're going to want to be able to do a few key things here. One would be identifying a quadratic. We also want to be able to FOIL to identify the coefficients in a quadratic, graph the quadratics using a calculator, and also identify our vertex, axis of symmetry, domain, and range of the quadratic function. So we use this as a checklist to see if did we accomplish everything that we wanted to accomplish in this section. A couple quick things about quadratic functions. One would be that it needs to be written in the form, or can be written in the form, ax squared plus bx plus c. Now, not all quadratics will be written in this form, but it can be written as such. So, for example, we have f of x equals 2x minus 1 times 3x plus 5. And here it's asking us to show that f represents, meaning f of x represents a quadratic function. We also want to identify a, b, and c. So essentially what it's asking us to do is to put it into this form here. Well, we've seen this before, and we can do something called FOIL, which I know we all love to do. So we have 2x times 3x gives me 6x squared. 2x times 5 gives me 10x. Negative 1 times 3 gives me negative 3x. And negative 1 times 5 gives me negative 5. So I've multiplied those two binomials together. Now I'm going to combine my like terms. So we have 6x squared plus 7x minus 5. Now if I want to identify a, b, and c, I look at my coefficients, 6, 7, and negative 5. So a is 6, b is 7, and c is negative 5. Now, although you may think, well, what's the point of these coefficients right now? Who cares what a, b, and c are? We will be using those later in a couple different formulas. So it is important that you know how to identify a, b, and c from a quadratic function. And the only way to do that is to have it in this form here, where we have ax squared plus bx plus c. You cannot identify a, b, and c when it's in a factored form like this. Feel free to try this one right here, and then when you're ready to see the answer, hit play. So go ahead and I FOIL it. I FOIL this, and we end up with 12 minus 4x minus 6x plus 2x squared. Well, I need to rearrange that, put that into descending order, so highest exponent first, and then so on and so forth. So I get 2x squared minus 10x plus 12, so my a, b, and c are 2, negative 10, and 12 respectively. Now we're asked to determine whether or not the following functions are quadratic. It kind of goes back to when we were determining whether or not something is linear. Well, there are key things that we look for when it's quadratic. First off, if you're plugging it into your calculator, you should see something like this or something like this. That basic shape. Remember, with linear, we were looking for straight lines. Well, here we are looking for this U and N shape. Those are the types of shapes that we're looking for. We're talking about quadratics. Well, with quadratics, it's the fact that we have an x squared that's making it a quadratic function. If I look at this one here, I have 6x squared, and I have my negative 2x. Well, I can basically write that in the form 6x squared minus 2x plus 0. Well, that's just like the form that we had on the previous slide. This would be a quadratic. Yes, it is. Here I have 24 minus 3x. Do I have an x squared? Nope. It's not just about having an x squared. There are some special cases like number 3 here. Do I see an x squared? I don't. But if I were to FOIL this together, and when I multiply negative x times positive x, I end up with an x squared there. So my answer would be yes. If I were to FOIL that together, kind of like I did on the previous slide, I would end up getting an x squared, and that would give me a quadratic right there. Let's check out the last one here. Now, I have an x cubed. Well, that would mean that it's cubic. However, if I look at this 2x here, can I divide 6x cubed by 2x? Yes, I can. Can I divide 8x squared by 2x? Yes, I can. Since I can divide both parts in the numerator by this 2x, I'm allowed to reduce. Normally, we aren't able to because you can only really cancel out one or the other, but we have to be able to cancel with both. In this case, we can. So 6 divided by 2 is 3. X cubed divided by x is x squared. See how those exponent rules come into play here again. And then we have 8 divided by 2 is 4, and x squared divided by x would give me x. So what I'm left with is 3x squared minus 4x, which is a quadratic function. So yes, it would be.